In this video, we're going to look at what to do in probability with factorial using letters. And so if the letters are identical, so if there's an E and an E, when I swap them around, I won't notice the difference and get an extra option, then all I do is I just divide the answer that I get by the factorial options of all the repeats. And so if I gave you the word needed, there's 3 E's and there are 2 D's. So just keep that in mind as we go through the question. How many 6-letter words can you make? So there's 6 letters, so it's 6 factorial, but because they're repeats, there's 3 E's, so I'm going to divide it by 3 factorial, and there are 2 D's, so I'm going to divide it by times 2 factorial. What happens if I want to start with an N and end with a D? In our previous video, we saw that we do these specifics first, and so starting with the N, there's only one N, so I don't use factorial when I have specific positions, I just write 1, and ends with a D. I'm not going to do this middle number part of the question next. I'm going to do the specifics, the D. There's 2 D's, so how many could end? It would be 2, and it will be 1 times 2 at the end, and I've used up 2 letters. I've used up a N and I've used up a D, so there's 4 letters left that can go anywhere, and so it will be 4 factorial in the middle. And what does that go over? It goes over the total, which I worked out in the first question. Let's do one that's a little bit trickier. So given the letters that spell Yanni Strauss, how many 11-letter words can I make? So let me just look and see. There are 2 A's, there are 3 S's, and I think those are only repeated letters. So how many 11-letter words? So it will start with 11 factorial. We're just using all our options, but we divide by the repeats. There's 2 A's, so we divide by 2 factorial, and 3 S's, so we times that by 3 factorial in the denominator. This is our grand total of options that we could have, just over 3 million. What if GIT, those letters want to always be together as one unit? This is the zoom in, zoom out method that I taught in the intro to factorial. And so if I zoom into these letters, they can move around 3 factorial because there's 3 letters, and then I zoom out. I'm just going to do it up here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 letters, and so 3 of them, let's just pick these 3 here, 3 of them want to always be together. So I zoom out, I zoom in and I get 3 factorial here, and then when I zoom out I count them as one entity, so it will be 1, 2, 3, 4, 5, 6, 7, 8, and this counts as one entity, 9. That's how I got the 9 factorial, and I divide it by the grand total. Last question, I start with an A, so let me do that first. There's 2 A's, I don't put a factorial with it, it's just there's 2 A's that I could choose from, and then I next do the other specifics, which is the S. There are 3 S's at the end, so there I put 3. Out of my 11 letters that I could have chosen from, I've only used up 2 letters, the start and the finish, so 2 letters have been used so far. So how many letters are left? There are 9, and they can go anywhere, so it will be 9 times 9 factorial over the grand total, and that gives you your answer. I hope that makes it a little bit easier for you when you get these slight variations and complexities with repeats, letters, start and finishing. If you found that helpful, please like our video, subscribe to our channel, and share it with your friends.